Let's take the sine of an inverse cosine. We have the sine of the inverse cosine of x over 3. We want to write that as an algebraic expression. Now we have to assume that x is greater than 0 and that x over 3 is in the domain of the inverse cosine function. Alright, we have to begin on the inside, focusing our attention on the inverse cosine. First thing to note is that the range of the inverse cosine is from 0 to pi, and that becomes apparent later. When we take the inverse cosine, we're actually looking for an angle, and a good step is to write theta as being equal to the inverse cosine of x over 3. And from that we can take a step backwards to say that the cosine of theta is equal to x over 3 as long as it satisfies the requirements for the range and the domain for those functions. So alright, let's look at this a little bit closer. The cosine is positive. Within this range, that has to occur in quadrant 1. And so our reference triangle will look something like the following. We have the cosine of theta, this is the angle that we're looking for, is equal to the adjacent x over the hypotenuse 3. Now from this triangle, we're actually looking for the sine of theta, again where theta was the inverse cosine of x over 3. Sine, we know, is the opposite over the hypotenuse, and we have to come up with an expression for the opposite side here. We can use the Pythagorean theorem to come up with the following, knowing that 9 minus x squared is equal to that right-hand side, and we cannot forget the square root there. So it's the square root of 9 minus x squared. So let's put all this information together. We want to take the sine of theta. From that, again, we get the square root of 9 minus x squared, all over, in this case, 3. And so the sine of the inverse cosine of x over 3 is the square root of 9 minus x squared, all over 3.